So hello friend, this is Kaustuv Pathare and again with a new video. Welcome to our channel Making Maths Easy. So the previous video was based on matrices and determinants. It was a part 1 on matrices and determinants. It was half completed. So today in this video I am going to complete the part 2 on matrices and determinants. So let's start our video. So in this video we are going to complete types of matrices. What are the types of matrices? So the first matrix is a row matrix. So what is a row matrix? Row matrix is a matrix which contains only a row and not a column. So row matrix can be defined as a matrix that contains only a row and that doesn't contain any column. So 1, 2 and 4, 1, 3 and 4, the matrix having 3 columns and 1 row. So this matrix can be treated as a row matrix. So what is a column matrix? A column matrix is nothing but a matrix that contains only the columns. That can be treated as a column matrix. So this matrix contains only columns as 1, 4, 6. So this matrix can be treated as a column matrix. The matrix that contains only the column is called a column matrix, whereas the matrix that contains only the rows is called as a row matrix. Zero matrix or a null matrix. What is a zero matrix or a null matrix? So it is important. A matrix that contains nothing. A matrix that contains nothing is called a zero matrix, or we can say a matrix that contains only zero, only one zero, can be treated as a zero or a null matrix, or we can say it can be one dimensional or 1 degree, it can be 2 dimensional or 2 degree, or it can be 3 dimensional or 3 degree. So it may contain 2 zeros, it may contain 4 zeros, or it may contain 6 or more than that, or we can say it may contain 9 zeros also. So it is treated as a zero or a null matrix. What is a square matrix? Square matrix is quite simple, as I told you. As you know in the previous video, what is a square matrix? A matrix that contains equal number of rows and equal number of columns is known as the square matrix. Means number of rows are equal to number of columns. Such we can consider that 1, 3, 4 and 5 is a matrix. So this matrix is a square matrix as it contains 2 rows and 2 columns. Okay, as it contains 2 rows and 2 columns. So this can be treated as a square matrix. Another matrix is the matrix which is not a square matrix. The matrix which is not a square matrix can be treated as follows: which do not contains equal number of rows and equal number of columns. So in this matrix we can say it's not a square matrix. 1, 5, then 4, 6, and then 7, 8, 6, 7. Sorry, 6, 7. So this is matrix. This matrix is not a square matrix because it contains 3 rows and 2 columns. So this matrix cannot be treated as a square matrix. Then the next is a diagonal matrix. What is a diagonal matrix? Diagonal matrix is a matrix that contains the diagonal elements equal to some number. Diagonal elements are having some number, but the rest of the elements are equal to 0. Let's say 2, 0 and 0, 7. So this is a diagonal matrix, as diagonal element 2 and 7 consist some number and rest of the elements are 0. This matrix can be also generalized as follows. So we can make this matrix as a big matrix, means 2, 0 and 3 by 3 matrix. So this may be 0 and this number will be equal to 6 and this will be 0, and again this number will be equal to 0. This number will be 0 and this number will be 7. So this is a type of a diagonal matrix, as diagonal elements consist the sum of the values. Diagonal elements must be non-zero in this case. In order to prove a diagonal matrix, diagonal elements must be non-zero. So what is a scalar matrix? A scalar matrix is a matrix whose diagonal elements are same. So let us consider a matrix as a scalar matrix. I am giving an example of scalar matrix. Let us consider a matrix having elements as 2, 0 and 0 and again 0, again 2, again 0, again 0, again 0 and again 2. So this matrix can be considered as the scalar matrix because the diagonal elements are same in this case, as 2, 2 and 2. Diagonal elements are same. If we interchange this number, if I write here as 2, so and if I write here as 2, so it will also be an scalar matrix because the diagonal elements are same in this case. And if I interchange this 0, 0, so this is a type of a scalar matrix. A scalar matrix is a matrix in which the diagonal elements are equal. Diagonal elements are equal. So let's move to the next matrix. The next matrix is the unit matrix. What is a unit matrix? A unit matrix is a matrix having all the ones and zeros, in which all the diagonal elements are ones and rest of the elements are 0. So example of unit matrix is 1 0 and 0 1. So this matrix can be treated as a unit matrix, because in this matrix the diagonal elements are 1 whereas rest of the elements are 0. So this matrix can be treated as a unit matrix. Another example of the unit matrix is this 1 then 0, three-dimensional matrix. So in three dimension, there are three ones. So 1 0 again 0 again 0 again 1 again 0 again 0 again 0 and 1. So this is a unit matrix. In unit matrix all the diagonal elements are 1 except all the elements are 0. Okay. Then next is my upper triangular matrix. What is upper triangular matrix? Upper triangular matrix is nothing but the below elements are 0. In upper triangular matrix, the below elements mean the elements below the diagonal are 0. So example of upper triangular matrix can be 1, then 2, then 3, and then 0, then 4, then 5, then again 0, then again 0, and then 7. So in this matrix the triangle means the element below the diagonal, this is a diagonal of a matrix. 1 4 and 7 is a diagonal of a matrix, this, and elements below the diagonal are equal to 0. So this matrix is called as a upper triangular matrix. The same for the lower triangular matrix. So in the lower triangular matrix the elements above the diagonal are equal to 0. So let us take an example of lower triangular matrix. So we can take the number as 1, then again 0, then 0, then 3, then 5, then again 0, and then 6, then 7, and then 9. So in this matrix we can say that the triangular elements or the diagonal elements are 1, 5 and 9, and the elements above the diagonal elements are 0. Means these are 0. This triangle is 0. Elements or the triangle above the diagonal elements are 0. Whereas in this matrix the elements below the diagonals means this triangle is equal to 0. Whereas in this matrix the element above the diagonals are equal to 0. So this matrix is a lower triangular matrix in which the elements above the diagonals are equal to 0, whereas in which the elements below the diagonals are equal to 0 is called as the upper triangular matrix. So let's consider our next matrix. The next matrix is symmetric matrix. So what is a symmetric matrix? A symmetric matrix is a matrix in which the mirror elements are same. So let us consider a matrix in which the mirror elements are same. So this is a matrix. This is a 3 by 3 matrix. We will take first element will be 2, next element is 5, and this is 7. So now this will be 5, and this is the mirror of 5. Means we will consider a diagonal. I will show you. After 5, next element will be equal to 6. Another element with this another element will be equal to 9. Then this element will be 7. Then this element will be equal to again 9, and this element will be equal to 0. So now carefully look at this matrix, as we can say that this is a diagonal which divides the matrix into two triangles. This is one triangle and this is another triangle, and we can see that means the mirror elements 5 5, 7 7, then 9 9, except this 2 3 6 and 0 are similar. Okay. Whereas in the asymmetric matrix all the elements are dissimilar. Okay. In symmetric matrix we can say that the mirror elements except the diagonal, means a diagonal that divides the matrix into two triangles, and the mirror elements are equal to equal, we can say. So a symmetric matrix is a matrix in which the mirror elements are equal, always equal. So this matrix can be considered as a symmetric matrix, as they are having equal number of mirror elements. 5 5, 7 7 and 9 9 are the mirror elements of the corresponding matrix. Symmetric matrix can be only possible when there is a square matrix. We can also perform the lower and upper triangular matrix can also be possible when the matrix is a square matrix. We can say 3 by 3 matrix, 4 by 4 matrix, it is possible. Okay, or 2 by 2 matrix. So let's consider our next matrix. The next matrix is a non-symmetric matrix. Similarly, non-symmetric matrix is same. If I change these values, if I put here 3, if I put here 0, if I put here some else value as 6, so this can be considered as a non-symmetric matrix. In non-symmetric matrix none of the elements, none of the mirror elements in the matrix are same. Okay, none of the mirror elements in the matrix are same. All the elements are different in the non-symmetric matrix. So the matrix can be considered as a non-symmetric matrix. So next is matrix is a singular matrix. A singular matrix is nothing but a matrix whose determinants are equal to 0. Consider a particular matrix as matrix A, whose elements can be given as equal to 4 comma then 2 4 then 2 then 6 and then 3. So the determinants of these elements will be equal to 0. Let us consider a determinant as capital A, and determinant will be equal to 4 then 2 then 6 and then 3, and 4 3s are 12. So 12 minus 6 2s are 12 will be equal to 0. 12 minus 12 equal to 0. So this is a singular matrix whose determinant is always equal to 0, and singular matrix is only applicable only for a square matrix as 3 by 3 matrix, 2 by 2 matrix. I have shown the example of 2 by 2 matrix. What is a non-singular matrix? Next is a non-singular matrix. A non-singular matrix is a simple matrix whose determinant is non-zero, whose determinant is not equal to 0. It consists of value, and it may be positive or it may be negative, but it should have some value whose which should be non-zero. So let's move to the next topic. The next topic is our determinants. So friends, here is a new topic that is called determinants. Okay, so before moving to the determinants, let us know some of the properties of determinants. So these are the some of the properties of the determinants. The first property is, if the rows and columns in the determinants are interchanged, if the rows and columns of the determinants are changed, then the value of determinants remains unchanged. Okay, if the rows and columns of the determinants are interchanged, then the final value or the final answer of the determinants remains unchanged. Okay, if you interchange the rows, if you interchange the column, the final answer will come the same. Second property is, if the two rows and columns of the matrices are identical, then the value of determinant is equal to 0. If the two rows and columns of the matrices are identical, so consider two rows of the columns having 1 1 1 and 1 1 1. If the two rows, or consider two columns as 1 1 1 1 1 1, if they are identical, okay, then the value of determinant is obviously equal to 0. You can get the value of determinant will be equal to 0. Third property is, if there is a common factor, if there is a common factor in each and every row and column of the determinant, it can be taken as a common. If there is a common factor, let's say consider as 5 by 2, 5 by 2, or we can say 5 by 3, or we can say 5 by 5, or whatever it is. If there is a common factor in a determinant, so we can take a common factor outside the determinant as a common, and then we will solve it, and then we will multiply the common factor with the given corresponding determinant. So friends, here is our new topic, that is determinants. So let's talk about the determinants, and let's talk its parts of the determinants. What are the major things while solving the sums based on determinants? So the first is minors and cofactors of the matrices. What is the minor and cofactor of the matrices? A minor of a matrix is nothing but the portion or the elements which are left below the horizontal and vertical line of the corresponding matrices, and taking the determinant of it is called a minor. So let's consider the minor of A11 as A11, the horizontal line, it makes a horizontal line as A11, A12, A13, and it makes a vertical line as A21, A31, and the minors are A22, A23, A32 and A33. So these are the elements which we have to take the determinants, which we are going to take the determinants in the minor. So minor of A11 is the determinant of these four elements A22, A33, A23, A32 and A33. Similarly, consider the minor of A12. So the horizontal line, vertical line is this A12, A22 and A32, A11, A12 and A13, and the elements which are left are A21, then A32, then A31 and A33. So we have to take the minors of those elements. So take the determinants of these elements. So A21, A23, A31 and A33. Similarly, minor of A13. So the minor of A13, take this horizontal line and take this vertical line. So this A11, A12 and A13 will be a horizontal line, and A13, A23 and A33 will be a vertical line, and this portion, only this portion, we have to take the minors. We have to find the determinants of this portion as A21, then A22, then A31, and then A32. So we have taken the determinants of A21, A22, A31 and A32. So in this way we have to find the minors. So how to find a cofactor of a element? Cofactor of the element is nothing but -1 raised to the given element addition. So this can be cofactor of the element. If we have to calculate the cofactor of say A11. So -1 raised to -1 raised to 1 plus 1, and 1 plus 1 is nothing but equal to 2. So -1 raised to 2. Similarly, we have to find a cofactor of A12. So A12 -1 raised to 1 plus 2. If it is A13, A14, it will be -1 raised to the given 12 or 13 or 14, whatever it is. Let us consider the cofactor, find a cofactor of A13. So this will be -1 raised to 1 plus 3. -1 raised to 1 plus 3. Okay, if it is 1 plus 1 4, then it will be 1 plus 4. If it is 1 5, then it will be 1 plus 5. If it is 2 1, then it will be 2 plus 1. Only -1 raised to the given means ij value. So friends, let us teach how to solve the determinants. So we have taken a 2 by 2 determinants as AB into ABCD. So whose answer is equal to AD minus BC. So we have to cross multiply that A multiplied by D minus B multiplied by C, and we have to subtract it. Only we have to cross multiply and we have to subtract. So let's consider a 3 by 3 determinant, or a determinant with 9 elements as A, B, C, D, E, F, H, I, J. So in this determinants of 9 elements, we have to do same thing at that of the minors. We have to find the minors of each and every element. So consider this A, and A has having the row and column. So we have to neglect that row and column, as this ABC is a row for A and ADH is a column for A. So we have to neglect this and we have to consider only this EF and IJ. So we have to consider the minors of EF and IJ. So minors of EF and IJ is E into F minus E into J minus F into I. So A multiplied by E into J minus F into I, or I into F. Again minus B means we have to do in this way at that as plus minus plus minus. Okay, plus minus plus minus. In this way we have to do. Okay, first will be plus, second will be minus, then it will be plus. After if it is coming anything, so that will be also equal to minus, because it is in the form of plus minus plus minus. So next is minus B. So this is my B, and consider the row and the column. So B is having the row as B, E, I, and A, B, C is my B, E, I is my column, and A, B, C is my row, and the rest of the elements are D, H and F, J. So we have to cross multiply that. So D multiply by J as DJ minus F multiply by H, FH minus FH. Similarly means minus B multiplied by DJ minus FH, or we can also say that minus B into minors of this B, minors of this B. Similarly A multiplied by minors of this A, minors of this A, B multiplied by minors of this B, and C multiplied by minors of C as minors of C. So this is, let us consider C. In the C, this is my row and this is my column, means ABC is my row and CFJ is my column, and the rest of the elements are D, E and HI. So we have to cross multiply it. D into I minus E into H means DI minus EH, and we have to multiply it with C, means C multiply by minors of C. C multiply by minors of C is DI and EH. So friend, this was a part 2 video for today's lecture in matrices and determinants. So hope you like the video. If you like the video, please share, subscribe and comment on my YouTube channel. Please like the video. and also please press the bell icon, so if I upload any new video you can get the video notification. I'll also subscribe my channel. So thank you for watching. Thank you guys.